Hey there everyone, the focus of this presentation is on soil horizons and pedons. So the outcomes of this discussion is on describing differences among soil mineral horizons, the A, B, and C horizons. You'll learn to identify a few soil horizon modifiers, and you'll also deepen your understanding of what is a soil pedon. Now let's think about a native soil profile. In other words, a soil that has developed for hundreds of years under a stand of trees or in a grassland environment or the alpine. Processes that we talked about in the previous class, think about calorped, they tend to act from the top and weaken as you go downward in the soil profile. Over time, layers, these soil horizons, are formed. Young soils tend to resemble the parent geologic material, the PGM, the most. In other words, the materials that you find in the sea horizon or the bedrock. And horizons, how you differentiate different horizons depends on the properties, such as color, structure, texture, which was the focus of the last lab, consistence, and chemical properties. The A horizon is a surface mineral horizon that tends to contain the largest amount of organic matter, of OM. So this is where you find an accumulation of organic matter. It's also the maximum loss of materials by suspension, solution, and erosion, and the greatest energy transfer. So this is where you get inputs from the sun or other biological materials like inputs from surrounding vegetation or soil fauna or microbial activity. The B horizon, and sometimes there's a B-C transitional horizon, tends to be a subsurface mineral horizon that includes some of the materials from the upper A horizon. So some of the materials from the A will accumulate in the B. The C horizon is essentially a slightly to unaltered parent material. This is where you can discover what was the origin, what was the parent material of the soil. And like I said, sometimes there are transitional horizons, A, B, C horizons that may occur as well. Now, there's such a thing as soil horizon modifiers. So these are sort of descriptor, lowercase letters that help to explain some of the processes or factors that are playing out in the formation of the soil. So a few examples are an E, lowercase e, so this is an indicator of alluviation, which is the movement of clays or salts or other particles that are dissolved, and they move down from, say, the A horizon into the B horizon, and they'll accumulate in the B. Sometimes we refer to this as leaching, although there is some slight differences. Lowercase a means enrichment of organic matter. Lowercase f means enrichment with iron oxides. G refers to a horizon that is gleyed, and T refers to a horizon that's enriched with silicate clays. We'll explore these in more detail in coming lectures and exercises. So just to give you a sense, so when you see a description of a soil horizon, so this is an example, what you see are these lowercase modifiers along with the capital A's, B's, and C's. So at the top you have LFH, so this is an organic horizon, and the remainder of the horizons are mineral horizons. So an AH indicates an accumulation of organic matter. The AE is a layer where there's some alluviation that's occurring. In other words, loss of clays. Then there seems to be a little bit of a transition zone here, and then we get into a B horizon where there has been eluviation, so an accumulation of these clays from the A horizon. Recall, clays are the finest particles, so they tend to move through the soil profile, and so forth. So have a look at this on your own time, and just to get familiar with the different horizons. Now with soil pedon, we talked about this in class. Here are a couple of examples of soil pedons. And when you're in the field, you're going to ask yourself, how wide is a pedon? In other words, how big should my soil pit be? So in general, 1 meter is the horizontal distance that you want. There are some exceptions, and I sort of touched on this. So sometimes you're going to want a wider pedon, about 3.5 meters, if you encounter soils that are more cyclic or intermittent in their formation. So an example of this would be a cryosolic soil, which is found in permafrost environments. So check this out. It looks like the psychedelic soil. It doesn't have these horizontal horizons. Instead, the soil thawing the ice thawing and freezing sort of churns the soil, and you get this psychedelic formation. In other words, you would need a much wider soil pedon to capture the variation in the soil. Now, how deep do you go? Generally, in a mineral soil, you'll go 25 centimeters below the upper sea horizon, or to a depth of 2 meters, whichever is less. For the purposes of our class, at times we just need to dig as deep as it's feasible. We don't always have the time to dig a perfect soil pedon. There are some exceptions. If you hit bedrock, you're of course not going to dig into the bedrock. Organic soils are a different story, and we'll get into more detail about that in a coming lab in a few weeks. So, a formal soil description, you always start at the top horizon, you work your way down, and you describe each horizon based on some of their physical properties. And let me just say that this will be the focus of the next 2 videos on soil physical properties. Thanks.